organizational performance with substantially less risk of destroying value when compared to some short-term type of approaches. Lean is a never-ending journey, and you don't just start it and magically complete something and then that's all over. We go on and on and on trying to improve that. Today we're going to try to outline some of the many concepts and tools that people use in planning, implementing, and measuring and monitoring their processes. The word quality will be used a lot since we learned that variations are the opposite of quality, and by reducing variation and improving the flow or the process speed, we can embark on a road of continuously improving the process. I've been a follower of W. Edward Deming for a long, long time, even before I entered the dental industry and when I was back in the computer industry and providing solutions to a variety of businesses. But it really came back to me after I got involved in this, then, just what he had done. He was a principal designer of the Japanese systems that brought that nation back to itself after World War II. Deming's principles really, one of the statements that he made, and I'll never forget, is that he said, you cannot inspect quality into a product. You've got to build it into the product. And after being acquainted with so many dental labs and their processes, it struck me as so apropos to our business, and I became even more of a fan of his at that point. He also said experience by itself teaches nothing. And this kind of emphasizes the need to interpret and apply the information that you have against the theory or conceptual ideas that is the basics for the knowledge of a system. Deming wrote out 14 points for any kind of a process improvement organization that an organization wants to do. He said you've got to create a constancy of purpose so that you are continuously improving your processes. This requires that you're both short-term and long-term problems, that you identify those, that you allocate the resources appropriately, and you work to improve both product and service design. He said you've got to adopt a new philosophy of quality management, constant learning, embracing change, and focusing on the customer. You have to cease dependence on inspection as a means of ensuring quality. As I said, you can't build quality into a product. You've got to, or you can't inspect quality into a product. You've got to build it in there. He said instead you've got to place much more reliance on the statistical tools for assessing quality. He also said that don't award simply on the lowest price. Don't buy your supplies and your products based upon lowest price. Don't depend upon a lowest price as far as what you're doing as far as your customer is concerned. Change your focus so that you are incorporating quality, that you become a sole source if all possible, that your relationships and other factors are in the eye of the doctor that you're dealing with. He said search continuously to improve the processes, become innovative, and look at the overall flow or systems in terms of the design, the inputs, the materials, the maintenance, the supervision, the automation, the training, teams, waste, everything about that that generate innovation. And he said invest in great training. Keep your people productive and innovative. Bring new skills about for improvements. Fuel this process by empowering your people to do their very, very best. Institute leadership that goes beyond the numbers and instead puts an emphasis on supporting and making sure that people can execute. Leadership's got to be able to discern what's important and what's not to optimize how the resources are applied. Drive out fear. Encourage people to make mistakes. Encourage people to make trials and try new things, and not condemn them if it, in fact, does not go the way that you think it should. Break down the barriers with the whole team, both from your suppliers to the team members that you have and your customers, and promote that communication across all of these players. He said eliminate, the decisive actions such as slogans or exhortations and targets that can be counterproductive, really, for what you want to do. He also said avoid the numerical quotas and just thinking more in terms of one of the principles of lean is quality at the source. And make sure that that is what you're doing. Allow the pride of the workmanship. And make sure that the senior management is committed to this at all times. There's a second pioneer that I've learned since I started with all the lean work is a guy named Joseph Jurin. And he advocated a lot of the same processes and stuff that Deming has. However, he took the concept really much more so into the customer's ideas. He really argued that quality has to be linked to the customer, and that is really the premises of lean that you need to embrace and understand. You just can't look at a product going out the door in a case pan and say, okay, it's all right, and do that. And to understand that, and his list of 10 things, is you've got to identify your customers. When I say that, it means that you've got to really understand who they are, what they're about, where they are in their own processes. You can't provide a solution to someone that you don't know what their problems and their criteria are. You need to seek out and define what their needs are on it, and then translate that back to what your own capabilities are. Set up definite performance measures that you can test against what your expectations are from that customer. Develop the products and the services that match up with that. We want to optimize then, what we're providing for them. Whether it's price, whether it's quality, whether it's a combination of the two, whatever it happens to be. We also want to help develop the production processes based upon their particular needs and optimize those as we go along. Okay. Lean is an interesting thing. As you know, I'm sure most of you know out there, lean, of course, is an outgrowth of the Japanese ideas and stuff, although it goes back a lot further than that. But the father of lean, as far as Toyota was concerned, which is Tachi Ono, said, all we're doing is looking at a timeline from the moment that we get an order until we collect the cash. and how we can reduce that timeline by removing the non-value added waste. Now, I've often been asked about what the differences are between Lean and Six Sigma, and which is more appropriate for the dental lab to embrace. Six Sigma is a really complex discipline, and it's designed to eliminate any variances in your processes. And by doing so, you eliminate any kind of product defects. If you can obtain true Six Sigma, you would only have 3.4 defects for every 1 million items produced. Somebody equated that to a golfer missing one putt in 187 years if he played every day. So pretty good standards, but I don't think it's necessary for the dental lab. I really don't. But I do think that Lean, then, because of the fact that it involves a lot less training and it's a much faster process, can work extremely well, and we've demonstrated that with a number of labs throughout the country today. A Six Sigma project takes about 6 months. Lean, an average project on Lean or what we call a Kaizen event takes about 5 days, and that's maximum. We said earlier that everything that we do in the dental lab is part of the process, and that's going to include the process itself as well as the inputs and the outputs on this. The inputs being the materials, the information, the physical items that you get, such as impressions and so on and so forth, there, and information and prescriptions and so on. The processes themselves and what we're talking about, and finally then the outputs, which is the product ourselves that we're making, and how that we then can measure that performance as far as waste and low cost, high quality, and so on. It's important to really examine the entire process for ways that we can eliminate waste. A lot of the dental labs recognize that they have the waste, but identifying that waste in their processes can be a little bit more difficult. Lean will tell you that basically there are 7 non-value added activities that they call waste. I'm going to introduce you to what I think is an 8th, which I think is the waste of human capacity and human creativity. The first one is overproduction. And overproduction is interesting from the standpoint that we say, well, we don't overproduce in the dental lab. We build everything to spec. So we get a prescription in, we build a product, and it goes back out. If we provide more than what the customer wants or more than what the doctor wants, if we think that we need to be absolutely the most perfect thing in the world, but the doctor doesn't want that, we're overproducing. There's a lot of ways that we overproduce in the dental lab itself. And we need to examine that in relationship to what that customer really wants. If it's more than what the customer wants, if it's more than what that doctor requires, it's overproduction. Waiting. The average PFM takes about 6 hours to complete, between 5 and 6 hours to do so. And yet the average lab takes 8 to 9 days to get it out through the lab and back into their hands. Obviously, that product is sitting there at a great deal of time waiting then. And that is non-productive time. That is absolute, complete, and total waste that we need to examine how that we can improve that. Transportation. Moving that ubiquitous carts all over the lab, from one area to another, filled up with things. Can be a terrible waste as far as the dental lab is concerned. There are several dental labs now who have actually installed gravity feed items that allow items to move one at a time through the process and eliminates this transportation aspect of things. It does a number of things that we'll talk about, but most of all, it does eliminate that transportation problem. Motion is a serious problem within the dental lab. I have sat and watched dental labs that have, technicians that have fumbled and fumbled to find the right burr or the right cutting tool or the right item, and waste as much as 10 to 12 minutes looking for the right tool. If you have to get up and move around, and if you have to move all the way across the lab and everything, it's usually going to be a problem as far as motion is concerned. So we need to examine it and to find out how we can eliminate that. Inventory. Well, generally speaking, I think most labs are not bad as far as keeping supply items and inventory in that manner. You know, we sometimes overinvest in maybe in some metals and stuff at this time, and of course, as expensive as they are, that can be a serious problem. But the biggest inventory that the dental lab has is the work in process. Those items then that when we start then on that and we take a product that comes in and we add a little bit of labor to it, we add a little bit of material to it, and then it goes and sits, and then we move it along and we add a little more inventory to it, and it grows and grows in value. And by the time it takes 2 weeks to get that through that, then there is a lot of value sitting there in the cases that we've had on wait time. Variation is another item that is a major waste on it. The doctor, generally speaking, wants the same thing every time. He does not want any variation. My heavens, we all go to McDonald's to eat because of the fact that we know we're going to get a certain quality and it's going to be the same wherever we go, and it's not going to vary a great deal. It may not be high cuisine, but by the same token, it is going to be consistent, and there's not going to be this variation. And of course, finally, then defects is the major. Anytime that we've got any kind of rework whatsoever, then it comes back at us. Whether it's within internally or it's externally and comes back, then that is a major waste. As I said also, then, and I want to mention again that the waste of the human creativity and knowledge level that we've got. The people doing the work are the people who know the process better than anyone else. And if we don't take advantage of their skills and their creativity, then we're missing the boat, and that's a terrible waste. I think there's 3 strategies that we have to make sure that we're thinking about as we think about approaching the lean manufacturing process. We've got to put the right process leaders in charge. That doesn't necessarily mean that it has to be the owners or the general managers or whatever it happens to be. It could be that a team is put together, and it should be that a team is put together that really understand the situation and the full range of the process itself. We've got to adopt the tools that will help that process discovery. And we're going to talk about some of those tools here briefly. And finally, then we're going to try to make sure that we're agile in our approach to this, that we're not stagnant, that we make a change, we look at it, and we decided that maybe this could be done better, and we move back and change it again. Deming was the father, that I mentioned him, he was the father of what they call the PDCA, Plan, Do, Check, and Act. Well, I like to refer to it as plan, do, check, and adjust, because once we've got it planned out, we make the changes and we act upon that, we look at it and decide, okay, now let's try it again and see if we can do it better. So what does the team do? We select the right team and we get them in place. Obviously, first and foremost, they've got to define the key opportunities. I mean, there's a lot of processes that take place within the dental lab, both from administrative, production, supervision, and everything else. Where within that process do we need to make the changes and improve this? Once we can define that and what they are, we can begin to prioritize those and decide which is what we want to do. Generally speaking, getting started, I like to look at maybe some small opportunities, something that gives us a practice where we can get some wins and some victories under our belt and show off this success and get the training to move on to something else. And once we've done a couple of those, then we can begin to outline our timing better and know how to measure our success as we go along. Generally speaking, though, if we're going to make a change, there has to be a reason to make a change. I've been selling for most of my life, and I learned early on that if you're going to sell something to someone, there has to be a change in the status quo. We're not going to make changes if we're happy with the status quo. It just isn't going to happen. We've got to somewhat create a burning platform for the change. There has to be a reason. Then we've got to look at it and see exactly what that waste is and what we're going to do about changing it. We're going to develop then a specific plan. We're going to go out on the floor. We're going to look at it. We're going to watch it. We're going to watch the process that takes place. We're going to see what the actual time a technician is touching the product, how long it's sitting there waiting, and what we can do to improve that general process then. Then we're going to implement the changes. And, of course, finally, then we're also going to implement measurements and monitoring and sustaining efforts that we have to have as a result. This is some of the examples that I've seen in dental labs that they have used and said, this is the kind of a burning platform that we have and we need to respond to and try to fix. A lab had a rework rate that exceeded 7.2%. I know every lab kind of measures their rework rate a little differently. Personally, I feel any time that product has to go backwards in the process, that's rework. And I think you need to look at that and see if it has to go back for some contact adjustments, or if it's got to go back for some color changes, or if there's margin problems, whatever it happens to be, then we have got to consider that to be rework, at least for that particular time, and we want to correct it. So we need to establish what the rework is and say, okay, now if it's this amount or better, then this is a reason for us to institute some new improvements on it. One lab, because of some unbillable work, it determined that they had lost about $132,000 at that time year to date. It was almost the end of the year. That's a lot of money that they've lost in that. And I'm sure there's other labs that have lost considerably more. But that became their platform and says, we have got to improve our process based upon that. Another said 8% of their work they know was delivered late. Now obviously that creates considerable problems for the doctor and additional work on rescheduling and everything with that. Labs lead times from 10 to 12 days. And incidentally, many of those now have reduced that down to whether they're actually dealing in a 5-day or a 4-day type of a lead time that's in-house. Others have looked at their material costs and said it's gone up and up and up, and we've got to figure out a way that we can improve this and change this. And maybe it's different procedures, maybe it's technology, maybe it's the way we're buying. There's any number of reasons, but they did want to go into an improvement process based upon those. Secondly, I said you've got to see. You've got to go down right on the floor and you've got to look to see what's happening. This is an example of a value stream to be used in a dental lab. We just went through and we did a quick look to see what the process was and how much each of the processes were and how much inventory was in each of those. If you look at this, we've got our model room, our die trim, our waxing and so on and so forth, the various processes that we've got through here. Secondly, we've got the number of cases that are sitting there, which is an inventory item at that. This particular lab had the capacity to produce about 80 PFMs a day then. At the time that we did this, there were cases there that basically totaled 346 cases in process work, which was about 4.3 days worth of inventory at that rate. Yet they were taking 9 days to get those out, so that meant there was 4.7 days worth of delays in processing, which is a total waste to it. And ideally speaking, it would be great if we could bring a case in from the driver and it would go through the lab and back out and never stop. But we cannot obviously do that then. But what happens because of this is that you get a buildup as you go down, kind of a wave effect that the inventories grow as you go down. One of the things that we've done, of course, is that we have been able to come up with some smaller batches that we'll talk about and reduce this buildup that is so prevalent. But this is a value stream map, and this is just a great, great way to go through and analyze and get a quick snapshot of what's going on. We can then decide that, okay, we've got a problem at a particular place. In the model room, we've got a buildup. Or we've got in the casting, we've got a big buildup. What can we do to improve that process? And maybe we'll go into that rapid casting and we will do then a value stream on it itself and get into detail as to what takes place. There are a lot of tools that we use and a lot of tools that we think are important and that fall under the continuous improvement umbrella then. Whether it's 5 S's, whether it's quality at the source, it's cell design, and so on. All of these are important aspects of lean and things that we teach when we work with the lab to try to get them started on it. We talked about the value stream mapping and the value of laying that down. Quality at the source is basically an extension of Deming's idea that you can't inspect it and you got to build it in. One of the labs that I recently was at has 14 points of inspection in their lab, and yet they've got a remake factor of over 7% on it. So it obviously it isn't the case that all inspection is going to cure everything. The batch size reduction that we said can play a major role in this, and we'll talk about that in a little more length. Cellular design is basically one of the principles of that, because we want to make it easy. We don't want to have the process all over the lab. We want to get as much of it in one spot as we possibly can so that there can be easy handoff, easy communication between people, and without a lot of extra transportation and so on. So those are some of the tools. Now, all these tools are things that basically any lab can easily learn. There's no big secrets about these things, and there's a lot of efforts out there to on the internet, in textbooks, in classes, and with consultants to help the lab learn these processes and what they're all about. 5S is one of the major tools that I think is absolutely essential. And basically, if you've got excessive clutter, noise, and chaos and confusion, I think 5S is a great implementation tool. If it's a rework, then maybe we need to use the tool of equality at the source and the necessary steps to get that quality. If it's a large amount of work in process, then batch size is usually the way that we'll want to go to try to reduce that and get it down to a workable basis. If it is excess motion, then we need to look at the design of the lab and the layout. We'll do what we call a spaghetti chart. We'll take a case and we'll just follow it from place to place to place to place and show it and show all that movement on there. If we have a problem of communications, if we're not understanding the status of things, we don't really understand the prescription or what's been done, so on and so forth, what should be done, then maybe we need to get involved with some more visual controls on that. And we can take a look at that process also. The root cause analysis that we can do is another method that I strongly advocate that everybody get involved with. Usually, if there's a problem, it will boil down to one of four things. It's either manpower, materials, methods, or machines. And we can do what we call a fishbone type of an item here to determine what that is. If, in fact, that we say, okay, we got a problem that's such that involved manpower, and why is that? Well, maybe it's in training. But you can complete the fishbone and make it stronger and stronger and get it down to the actual cause of what the reasons are that it is a problem, actually. The basic, it's an extension. If you don't want to do this, you can also just simply do a 5 whys. Why? Well, we were late getting the product out. Why? Well, there was a machine malfunction. Well, why? Well, we forgot to do PM. Well, why? And boil it down to the exact reason as you're trying to determine what your improvements are going to be made. So root cause analysis is a great tool. The 5S, I think, is almost a foundation for lean. Any lab that wants to make an improvement has to be able to handle the 5S, which is sort, straighten, shine, standardize, and sustain. You cannot organize chaos, confusion, or clutter. You've got to do it on the basis of you're going to sort things out. You're going to distinguish those items that are needed for the process and get rid of those that are not. And you're going to put those in some kind of an orderly manner that will allow you to keep it straight, organized, and readily available for its use, and not be cluttered up with things that are not for that. We're going to keep it clean, neat, and all the equipment ready to go. The equipment is up to date. It's been PM'd. It's been maintained at the right schedules, and so on, so that can be done. Then we're going to standardize that. We're going to document that. We're going to make it a standard work habit then, so that we know then what has to be done. And finally, then we're going to work to sustain that and maintain those procedures as we go along. The standardized work, I think, is absolutely essential. Work instructions that document the best practices. We don't want to document something that is not working for us. But once we have worked and we have done that, we've got it right, then let's document it and make sure it's available to everybody. That serves as the best training methods and cross-training methods that we can possibly have if we've got the actual written instructions. Your standardized work includes all the methods of education that you've got to do to get people trained and make sure that they're on target with it. And the book should also show any kind of drawings, illustrations of the product, finished product that we want and what we're looking for, what we've got pictures of if we have to make decisions and so on and so forth with that. And we put our flow designs, our value stream maps in there to include that also. Finally then, of course, once we've got that, we've got to set up the measurements and be able to monitor and sustain that. There's audit procedures. Audits should be done on all processes on a weekly basis. And it should be done on a written basis so that you can grade what your kind of the inspect what you expect kind of a process. And sometimes it should be done by various groups. In other words, that the ceramic department can audit the model room, or the waxing people will audit then the stain and glaze process and what we've got with that. And set up then some tracking centers. Put it all in a book and in your documentation so that you've got the current map, future maps, all of your implementations, your metrics you got as far as your key performance measures, and all your communications together. And so that anybody and everybody can see that and make it visual to everybody of what we're measuring and how we're measuring it and where it's going. Some of the typical results that we've done as far as lean and putting it into place, then we have had anywhere from a 25 to a 50% improvement in the turnaround time. That's without a lot of effort. In some cases, it's been 100 and 150 and 200% improvement. If an outfit goes from 10 days to 5 days, that's a dramatic improvement on it. A 20 to 50% improvement in the quality. Eliminating rework, eliminating that process moving backwards then. We get a 10 to 35% improvement in the measurements then, so that we actually know whether we're hitting the targets or we're not hitting the targets. And we get an immediate improvement of anywhere between 15 to 20% immediately in our doctor approval and our retention rates as far as the doctors are concerned. And that's really what we're trying to do. We're trying to please them. We want to strive for a world-class organization. We want to do everything we can, and we want to look at it. If we're not meeting, if our outputs are not meeting the basic customer needs, our system is broken. If we're meeting some of them, then we need to look to see what we can do on a better basis. But we need a grade card that says, okay, this is where we're at, and we need to rate that on a regular basis as part of the lean process with this. I said we got to put the right people in place to do this. It can't be done on waving the magic wand, unfortunately, so it's got to get a team together that's going to be that. I propose the fact that we have a lean champion. I propose that we have somebody who is going to be the person that steps up and does it. And it does not have to be the lab owner or the manager. I've had several labs that have made major improvements because some team member has looked at it and seen that there is a need for that and stepped up and said, let's try this, let's try that, and they made those improvements, and it's worked. I've had several people attend courses and stuff that has gone back and said, we're going to try this and we're going to try that. And the result is that management then, after looking at it, says, you're right, it's a good idea. Let's see what we can do about incorporating it on a regular basis then. So, yes, I think that any improvement, any changes that has to be made, it has to be made with the consensus and the approval of the lab owners and managers. That's especially true if you're spending money to make the changes. If a lab owner is satisfied with this status quo and doesn't care to change, then it's going to be a little difficult to incorporate it. So they have to be a part of the thing, and they have to be sold on it. But they don't necessarily have to be the ones that initiate it and get it started. That somebody can do that and sell the idea without going into that process. Next month, we're going to do another webinar. And I will be doing that together with the people from the Pinnacle Group, which is Rebecca Lacey and Larry Lacey. And we're going to talk about the people side of lean, because I really feel as though the selection of the team members to do this and who they are and who becomes the champion, who becomes the drivers, and who becomes the advocates and so on of this are extremely important. Rebecca and Larry will spend some time with you and talk about how you select the people, how you evaluate the people. Someone once told me that there are 3 types of people in any kind of an improvement process as this. There was the advocates, the adversaries, and the ambivalents. The advocates and the adversaries, it's fairly easy to deal with because you know where they're at. The ambivalents then are a little more difficult because you don't know what's going on. They're simply saying, whatever, okay, you know, like my granddaughter, whatever. If I hear that one more time, I'm going to scream. But we can deal with those that are advocates, and we can deal with those that are adversaries. But when we're selecting the people, then we need to know, and how do we evaluate those people, and how do we look at it, and how do we select them? And they do a great job of giving you the guidelines of how you can analyze your people within your organization and how they will relate to the process of improvements. Before I sign off on this and myself, I want to make a special mention of Sarah Braun, who has been the facilitator on this. We have, as a company, have tried to maintain these webinars and keep improving those and doing these on a regular basis and then making them available to anyone who wants them on our website and so on. And Sarah has been behind this and driving this and facilitating this and taken up a lot of her time then. She's just another example of somebody within the organization who I think is deeply committed to making sure that our relationship with the dental labs is as strong as it can possibly be. So I will be glad to answer any questions that may have come in, if there are any, if I can do so at this time. Otherwise, I appreciate very, very much your attendance on this, and I look forward to talking with you again next month at that time for a little bit, although the vast majority of it will be done by the Pinnacle Group people. Sarah?
All right, thank you, Bob. So right now we'd like to go ahead and open it up for any questions. Please remember you can type them in the questions box on the right hand of your screen. So far, no questions have come in, so I guess we'll go ahead and wrap it up. But if you do have any questions that come to mind later, feel free to email us at webinar@whitmix.com, or you can email Bob Long directly at blong@whitmix.com. So thank you all for your attendance this morning, and we hope you have a great day.